Okay, so on the lab, on the last page, okay, let me kind of give you a visual of what's going to take place. So you have the same pulley system, but you have two different strings attached to it. So you've got a bigger mass on the smaller pulley, and then you've got a smaller mass out here on the larger pulley. So they're calling this M1, this is M2. So that's the diagram that I've got up on the board. So when you let go of it, look what happens. So you have this one falling, and you have that one going up, okay? So if you think about it, you have two conflicting torques. You have this one creating a torque, making it go this way, and you have this one acting as a torque against that. So what we eventually need to do is find the net torque. We need to find the torque created by this one and subtract that from this opposing torque on the other side. Now, which one has to have the bigger torque?
The bigger mass.
Yeah, because that's the direction that it spins. Now, this is where tension becomes key. These tensions are not the same, okay? So, here's the story. So, just focus, for now, just focus on M1, okay? Just focus on this one. So when I let go of that, what are the two forces acting on this system?
Gravity and tension.
Gravity is pulling it down, tension's acting upward, right? Cool with that. Now when I let go of that, which one is bigger? The gravity acting down or the tension acting up?
Gravity.
Gravity.
Gravity. That's why it falls in this direction. Okay? So on M1, and I'll go back over the screen in just a second. So on M1, the gravitational force is going to be a bigger number than the tension. So we're going to have this mass, so we're going to have M1 times G minus the tension is going to equal your net force. And your net force is going to be M1A. Now, on this side, over here, as that goes up, which one's bigger?
Tension.
The tension. So on this one, the tension is bigger
So
than the gravitational force.
T1 minus
So this one is going to be T2.
T2 minus M2.
Yes, equals your net force. Okay? So here's the story. You're going to have two different tensions. The one that falls, the gravitational force is bigger than the tension. The one that goes up, the tension is bigger than the gravitational force. Got that? Okay. So let me hook these back up so that they stay. Okay, so go and give this a spin. So here's what we just established. So here's M1, and that downward force is going to be M1G. So then over here, you have that tension 1. So here's the question. Which one is bigger, tension 1 or M1G?
M1G.
Because that falls, right? So if I take M1G minus tension 1, I get my net force, which is going to be what? M1A. But I'm talking about a spinning object. So instead of acceleration, what am I going to put?
Fish.
I can put M1 R fish. Now, which radius am I going to use? The R or the 2R?
R. 2R. R, because it's on the inside one.
R, because it's on the inside. R. Now, here's the story. What's going to happen over here on M2?
T2 minus M2G.
So, tension's going to be acting up, right?
Yeah.
M2G is going to be pulling it down. Which one's going to be bigger?
The
T2.
T2.
T2, because that's the direction that it goes. So over here, this is going to be T2 minus M2G equals M2A.
A.
But instead of A, I'm going to put,
R2 fish.
yes. Now, here's the story. At the end of the day, you need to find a net torque. You need to find the difference between torque 1 and torque 2, which is going to get you torque net. Okay, that's what you gotta find. So here's the kicker. How did you calculate torque on the previous problem? What numbers did you multiply together? Tension and
R.
radius, right? So if you look at what we did on the lab, your torque was tension times radius. So here's what you've got to do. You've got to isolate this T1. This turns into a huge algebra problem. You got to get tension 1 by itself. Tension 2 by itself is easy to do. You just have to add that over. Okay? All right? Because this one's a little bit more complicated because you're subtracting T1. So you need to isolate the T1s. So once you get those down here on this torque, so you're going to have tension 1 times radius minus tension 2 times a radius equals torque net. Now, at that point, torque net also equals I alpha. So when you get done, this is a multiple choice question. But let me put it this way. This is how much math it took me to get to the end. Okay?
Oh.
Probably one of the most complex algebra problems you will ever do. Okay? But that's how you at least get it started. I know May South people have got to go. So, here's the story on Monday. We'll discuss the lab. The calculations, if you lose track on how to do the calculations in the boxes, go to the analysis part. Okay? We'll discuss the lab on Monday. You'll have a review, test on Tuesday. Go, be free.
Wait, Sean, what?
So stop yonder camera.
Number 15? Yeah.